IHPRPT, delivering revolutionary capabilities to the warfighter. With the goal of doubling rocket propulsion capability, IHPRPT is a partnership between government and rocket propulsion industry. The program is technology-driven, goal-oriented, and application-focused to deliver revolutionary capabilities to the warfighter. The program addresses 3 mission areas: boost and orbit transfer, spacecraft, and tactical. Instead of chasing individual design points which can change radically over time, each phase is marked by quantifiable, measurable, and difficult but achievable goals which have to be demonstrated simultaneously. Achieving the goals for each phase effectively increases the design space of technology options available to future system designers. We make the future happen. Since its start in 1996, IHPRPT has had great success in boost and orbit transfer, space propulsion, and missile propulsion. Originally driven by a national desire for single stage-to-orbit capability, the integrated powerhead demo validated technologies for a highly reusable liquid hydrogen rocket engine that would be 20 times better than a shuttle engine. Some of the technologies will be incorporated into RS-68 engine upgrades for the Delta IV launch vehicle, where they will provide improved performance and increased reliability. Liquid rocket engine design tools have not changed in 40 years and are based on thousands of engine tests and failures over those years. Advanced physics-based modeling tools are being developed under the Upper Stage Engine Technology Program. The tools enable engineers to simulate, analyze, and design engines using outside-the-box technologies like hydrostatic bearings and shorten design cycle times by over 70%. Current Air Force strategy calls for operationally responsive aircraft-like access to space. The hydrocarbon boost demo is critical to this revolutionary capability. Leveraging numerous technologies, the project will demonstrate kerosene engine technologies, which will also provide the technology base for replacing the RD-180 engine on the Atlas V launch vehicle, assuring U.S. access to space. The Cold War is over, but the threats have become more global. Solid rocket propulsion developments under Phase 1 and 2 provide the warfighter with global range. In Phase 3, we are pursuing physics-based modeling, simulation, and analysis tools, advanced case insulation, propellants, and case and nozzle materials. These technologies enable 50% increase in payload for small satellite launchers used by the operationally responsive Space Office. Hydrazine has been a workhorse propellant for satellites, missile defense, and other Air Force applications for decades. However, it is highly toxic, requiring special suits and handling procedures. So we're now developing a family of ionic liquids that are non-toxic and have 70% better performance than hydrazine. We are currently transitioning these formulations to missile defense and spacecraft applications. Electric propulsion has great payoff for the warfighter. In 7 years, the micropulse plasma thruster went from a basic research concept to operational prototype. Our 200-watt Hall effect thruster flew on TACSAT-2, demonstrating a 5-fold increase in on-orbit life. Our multi-mode spacecraft propulsion efforts are addressing the warfighter need for operational flexibility. They leverage both chemical and electric propulsion efforts to provide high efficiency during peacetime and high-thrust operations when required to avoid space threats or change orbits to cover a theater of interest. We don't know what the future holds, but we will be ready. Aircraft-like operations to and from space, satellites zipping here and there, being able to reach anyone, anywhere on the globe in minutes. The technologies developed under the IHPRPT program will ensure preeminence for the Air Force and the nation.